Hi, welcome to my video on solving word problems using logs with the number E. I'm going to do some word problems in this video, but each word problem is going to be done by the logarithm unit that's in Algebra 2, which is the first unit, and then I'm going to do it with the number E. Let's start. $20,000 is invested at 3.5% annually for 10 years. Find the amount to the nearest dollar. So what we have the formula is AO, B, T over C. So AO is the initial amount, which is $20,000, and the rate R is, make that an R, 3.5%, and annually C is 1, and the time is for 10 years. So what happens? The rate, because it's an investment as growth, that means B is equal to 1 plus R. So what we have is, we're trying to find what A is, which is the amount that's at the end. AO is the initial amount. The base is 1 plus the rate, so it's 1 plus 3.5%. And the time is 10 to an increment of 1. So that gives us $20,000. And 1 plus 3.5%, 3.5% is 0.035. Decimal moves 2 places to the right, and we get 1. I worked it on the side so we don't have to keep writing down the formula. And 10 over 1 is 10. So if you pick up your calculator and turn it on, you have 20,000 bracket 1.035, put a bracket, and we're going to raise it to the power of 10. And this is the power button or exponent button, and we get 28211, or we could say 28212. So 28212, that's to the nearest dollar. So that's what we do in the unit in, say, grade 11 or 12 whenever we did it. But we can also do it continuously too, if you altered it into a unit. But the equation in continuously is AO, continuously is an E, and an R is rate, and T is time. So in this equation, AO is still the same, 20,000, E, and the rate is 3.5%, and the time is 10 years. So if you take the rate and change it to decimal 0.035 times 10, so we got 20,000 E, and multiply by 10, move the decimal 1 place to the right, so we get 0.035. And we use our calculator on this one now. I'm going to move the page up so you can see me using the calculator, but it'll give you, if I did it right, sometimes now E on my calculator, second function ln. E is second function ln on most calculators. Make sure you know where it is, and we're raising it to the decimal 0.35 power, and it gives us 28381. So that's 28381. 28381. So right here, when we did it in the normal way, we have 28,212. Just because this is continuous, you're going to get more interest, so we get 28,381. Okay, move the page back down. And that's one problem. I'm comparing the logs that's in grade 12 to what we're going to be doing in pre-calculus. A bond worth 10,000 grew to 85,000 in 6 years. Find to the nearest year the number of years when the bond is worth 18,000 from the 1,000. So what happens is that again we have an original amount. We could have, notice if I write down the equation, AO, B, and T over C. So what happens here is that we have we're trying to figure out what this is, but if you have these two, we don't have the base and we have the time. But if I go to find a time here, if I use this statement, find the number of years is T, but I go to 18, I got to go from the initial. So if I take the 18,000 and go from 1,000 to 18,000, I don't have my B and T. So I got to use the information that goes from 1,000 to 8,500 in 6 years. So I have to go and use this information first. So I take 1,000 and it's going to 85,000 and B, and the number of years, the increment is 1, so it's 6 over 1 or 6. So we divide by 1,000. So 8, that's 8.5 is B to the 6th. So that means we take 1/6 the power of each side. So 6 is cancelled out. So B is, and I'll work that out with a calculator, that's 8.5. And we got a power button. So the power button is here. And we got 1/6. So we put a bracket and go 1 division 6. And we'll get 1.42. That's 1.4285. So let's call it 1.42. We go down to that's tenths, hundreds, thousands, 10,000. The more numbers that I write down here, if I wrote down all those numbers, then I'd be more accurate. Okay, so that's the base. So if I want to use that base, so now I have to go AO, base, T over C again. So now I'm going from the beginning of 1,000 to 18,000, and the base is 1.4285, and we got to find T, and C is happening each year, so C is 1. So now this is the equation. So we divide by 1,000, we get 18, 1.428 to the T. And notice T is in exponents, and we have to do the log of each side to bring the T down. So the log of 1.4285 to the T, and we'll bring that up here. So we have log 18 equals T log 1.4285. So that means the log of 18 divided by the log of 1.4285 equals T. So we're dividing the log of 1.4285 into the log of 18. So T is equal to, and we'll work that out. So the log of 18 division. Oh, I didn't do a bracket, so I got to be careful. So I better do a bracket to close that off. Now I do my division and do the other log. So I got to put this in bracket to make sure. I got this bracket again. So I got 1.4285. Close it off. And I get 8.1 years. It says to the nearest year, so it's 8.1. So the time is 8 years. So that's doing it, what we did again in grade 11 or grade 12. Well, what about if we do it with E? Well, the equation for E is AO, E, and this time we could have an R and a T, but a lot of times if you look at books and depending on the teacher, you could have a what they call a plus or minus KT, and the K is the same as the R. But it depends on the book, depends on the teacher. So if we use R or K, it makes no difference. But this is the plus or minus. The plus is when you got a growth, the minus is when you got a decay. It's very important. So looking at this equation, if I have 85,000 and I'm coming from 1,000 E, so I'm going initial is 1,000, come from 85,000, 8,500, and I have as a growth, so the rate is 3%. So in 6 years. So notice we have it figured out. When I said 3%, now I don't know where I got 3% at, but I'm just thinking. So we're looking for our K, and it's a plus K, and the time happens in 6 years. So let's go back again. This is the equation. Initial is 1,000, going to 8,500 in 6 years. And so we're looking for the rate. So again, we divide, we get 8.5 E, and that's 6K. Now we want to find what K is, so we have to do the log of each side. And by the power rule, 6K goes in front of the log. So K is equal to the log of 8.5 divided by the log of 6 divided by 6 times the log of E. So I'm going to move the paper up, give myself more room so you can see the calculator. There we go. Making sure. Okay, here we go. I have it. So I have the log of 8.5 division, and I put it in brackets, 6 times the log of E. Log. To get the E, I got to go second function, log, and E is E to the 1, so I put a 1 in. I put one bracket, I put a bracket to close off this 1. Now I have to put another bracket to close off the log of. When I get that done, it gives me K is 0.357. So that's what K is. Now we go back and we put it when we want to go to 18,000. So the equation is AO E to KT. So we're going from 1,000 to 18,000, and K is 0.357, and we're looking for time. Divide by 1,000, we get 18. E to 0.357 T. Again, t is in the exponent, so we got to do the log of each side. Log e 0.357t, and by the power rule, the 0.357t goes in front of the log e, so that means we have t, which is right here. T is equal to the log of 18 divided by 0.357 log e. And we take our calculator and we work out. Let's see, move this up and get my calculator in there so I can see what I'm punching in. Here we go. Log 18 bracket division, and I better put it in brackets because I'm going to have multiplication, decimal 357 times log of e is ln, put a 1 in, double bracket, and we have 8.1. So the time is roughly 8 years. Again, the same answer is here as here, only I worked it out with E. Here I worked it out. Whoops. Bring the paper back down, talking to myself here, but not me. So this is the normal way when you use just as a base. This is when you use E, like it's continuously being compounded, continuously growing. Okay, we have one more to finish it off. Here we go. The volume of a balloon decreases exponentially by 3% every minute. The initial volume of the balloon is 200 cubic centimeters. When to the nearest minute will the volume be 40 cubic centimeters? And so we have a decrease, so we have the base is 1 minus r under the, if we're using with E, then the base would just be E. So we have a rate of 3%, and 3% is 0.03, and it's every minute, so C is 1. The initial volume is 200, and we want to find the volume at when it's 40 cubic centimeters, and we're looking for the time. So I can say the normal one will be VO, V equals VO times BT over C. So that would be VO would be 1 minus RT over C. So VO is 200. V is what is going to 40. It's 1 minus the 3%, so it's 1 minus 0.03. And we want to find the time, and C is 1. So we take 40 divided by 200. So 40 divided by 200 is 40 divided by 200 equals, and that's 1 subtract 0.03 is 0.97 to the t. So this is 40 divided by 200 is 1/5, which is 0.2, 0.7 to the t. And again, we do the log of each side. Seven to the t, and let's go up here. And so we got the log of 0.2. Power rule, the t goes in front. We get the log of 0.97. And so t is equal to the log of 0.2 divided by the log of 0.97. Oh, we don't need an equal, I already got an equal sign there. So work out that, I go log of 0.2 or 0.2, bracket, division sign, log of 0.97, bracket, and we get 52. So that's t is equal to 52.8, and it's in minutes, so to the nearest minute, t is 53 minutes. Okay, so that's using the equation where we, I put a t there, that's the base, and the base is 1 minus r. But when we use e, we got VO, so V equals VO the initial, E to the, again we can use RT or KT. But in this case we got to be careful. If I put K like that, then I can either put a negative with the K or wait till I go to put it in, but it got to have a negative. So if I put a negative with the K, if K is 3% decrease, then I can put the negative like that and take care of it. So it's going starting off at 200, deflating down to 40 E, and that's negative. So the rate is 0.03 times T is what we're looking for. And again, we divide this out and we'll get 40 divided by 200 is 0.2, and we have E to the negative 0.03 T. We do the log of each side. We practiced this before, doing the log of each side. And because we do a log to bring, I'm doing a log again because t is in the exponent, and the log will bring the exponent down by power rule. And so the log of 0.2, and I'm going to divide it by, I want t here, so it's a negative 0.03 log E. So again, move the paper up so you can see what I'm doing with the calculator. Very important for you to see what I'm doing, and you should practice with your own. So here we go. I'm doing the log of 0.2 and close it off, and I'm going to divide, and I got to use a bracket, make sure. I'm going to use negative 0.03 times log, and I need the E 1. You get used to it if you keep practicing. More practice the better. And you should get 53.6. 53.6. So 53.6, and this time, because we use E, which is continuous, we have closer. So it's 54. So the answer is, time is 54 minutes. So that's explaining when you did it in, say, grade 11 or grade 12. Now we're using E with all these questions. From now on, all you see is me using the E when I do word problems instead of using this equation here. I'll put the E in all the time. And again, repeat, this is the K, so this is a negative K, so it's the negative of the rate. If you just left it as K, then it would be a growth, it would be going up, but this is negative. And I just want to bring this back down. So if you like my video, click the like button. If you're not a subscriber and you wish to subscribe to my channel, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that's on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.